Hello everyone, and thanks for joining us in our ASUS Iot presentation of Solutions for Transportation. ASUS has been recognized as one of the leading technology providers over the past decades, offering products for the end consumers as well as commercial applications. Today, with the surge of IoT and AI, ASUS has created a whole new business group dedicated to this space. The ASUS AIoT Business Group has been created in order to help accelerate the adoption of new technologies in various verticals. Together with our ecosystem partners, we collaborate to deliver a complete solution to the end customer. The resources that we have allocated to the ASUS AIoT Business Group are proof to our commitment to the AI and IoT sectors. Our vision is to create effective solutions through innovation and partnerships. To achieve this, it is our mission to collaborate with ecosystem partners to deliver complete solutions. We also hope to become industry experts in our focus verticals. In order to simplify the path to adopting new technologies, ASUS AIoT product line includes motherboards, single-board computers, edge computers, AI accelerators, and more. We also provide a wide range of products in different form factors to cater for different demands. These products have been fine-tuned for a fast adoption, either by allowing for a quick setup or by embedding AI acceleration. ASUS AIoT is in constant search of the best option to accelerate the time to market. For this, we work closely with independent software vendors, solution orchestrators, value-added resellers and distributors, as well as system integrators, in order to better understand the latest market trends and cater for their needs. ASUS AIoT also collaborates closely with key technology partners such as Microsoft, Google, NVIDIA, Intel, and ARM to develop end-to-end products that allow for a quick deployment of the latest technologies. Today, we will give you an overview of the solutions that we developed for the transportation vertical. We will also present examples of success cases to illustrate how we collaborate with our ecosystem partners. In recent years, we saw a trend towards a continuous growth of urban areas, as well as the increasing need for a response to climate change. As the solution to these issues becomes more pressing, we have turned to innovative technologies such as AI and IoT. Two of the most noticeable trends are AI in transportation management systems and electric vehicles. Let's start with how AI is becoming ubiquitous in transportation management systems. Nowadays, video analytics has made it possible to identify vehicles by license plate number, car model, make, and color within minutes. This has increased efficiency and security on the road as we continue to improve operations in an ever smarter city. AI is also helping identify areas with most traffic at different times of the day, so that the traffic lights can be adjusted accordingly. These innovative traffic management systems are also informing first responders of incidents on the road in real time, so they can arrive on site as soon as possible. The increase in the popularity of electric vehicles has brought about changes in the critical infrastructure of cities, as well as consumer demand. EV charging stations will resemble current service areas by highways, offering more retail opportunities and restaurant services. Customers will expect an ever more connected service, allowing them to navigate the customer journey smoothly and seamlessly. This amount of connectivity and automation will require higher computation power at the edge, more integration among systems, and a close collaboration between the different stakeholders. In view of this, at ASUS, we're creating partnerships with companies in the space. The goal is to give our customers an end-to-end solution that is easy to deploy with all the hardware and the software components out of the box. At ASUS, we have created joint solutions with our ecosystem partners dedicated to the transportation sector. The first one that we can mention today is ALPR for access control. This is license plate recognition. It has become widespread for the automation of access control. At parking lots, Manual or token-based payment systems are quickly being replaced by sensors that detect license plate numbers at the entrance and again when they leave the premises. The technology is also very useful to manage reserved parking bays by integrating with ground locks that only grant access to the spot when the correct license plate is detected. Parking in public spaces is also starting to use license plate recognition for payment to increase efficiency. This has allowed governments to allocate staff to management tasks instead of deploying large numbers of people to do the same time-consuming job of physically checking and collecting street parking payments. ASUS Iot has developed a solution that allows for a quick license plate recognition even in harsh weather conditions. In terms of occupancy, currently many parking lots are using proximity sensors to detect available empty slots. Empty parking bays are marked by a green light right above the space, and the number of total available spots is shown at the entrance of parking lots. However, one of the main pain points that parking lot management has is the fact that when cars are parked incorrectly, for instance, when a car parks in between lines occupying 2 parking spots, they lose available parking space, but can't verify the exact situation unless they check physically. By using AI solutions for occupancy, precise information can be obtained in real time. For instance, if a car is occupying 2 parking bays, the software platform can be configured to trigger an alert so that management can respond immediately. Also, the number of empty spots can be adjusted in real time and displayed on mobile apps. Customers can then anticipate where to park without having to pull up to the entrance of different parking lots to know whether there is a spot available. Electronic vehicle applications are quickly gaining traction, as well as the infrastructure around it. EV charging stations combine features that we see in digital signage and self-service kiosks. In fact, many times they integrate more cutting-edge technology such as AI for targeted advertisement, touchless payment, and license plate recognition. We can automate payment by linking the license plate number of a user to the payment information they provide. And as charging the car takes some time, around the EV charging station, we can offer retail and restaurant services. This opens up a wide range of possibilities for integration of different systems, from content management systems for targeted ads to data analysis systems to understand the clients better. Also, payment systems that can link all purchases to the user's license plate number, a phone, or a credit card. We are currently building a Partners Alliance program with our ecosystem partners to make solutions easier to deploy, more connected, and more future-proof. Our partners range from AI software providers, business management system providers, payment software vendors, system integrators, and more. Most smoke and fire detection systems currently use temperature sensors. However, these sensors cannot accurately tell us how big the fire is and which are the exact areas affected. Here is where computer vision can help detect these incidents with more accuracy and in real time. These new video analytics systems can easily automate alerts, show real-time images, and even assign tasks to relevant members of staff. This improvement improves safety and response time. Traffic monitoring and traffic analysis is much needed to ensure a modern and convenient traffic system. However, it is a challenging task as traffic conditions are dynamic and require real-time attention. It is impossible to expect humans to monitor traffic 24/7, which is why most traffic monitoring systems are better at doing forensic search or at providing evidence after incidents have happened. The need for a real-time accurate analysis has helped improve video analytics technology. Today, we're able to optimize traffic flow and improve air quality and road safety at the same time. By installing sensors and edge computers on the road, we can collect valuable data that provides insight to control and optimize traffic. Data is collected in real time and sent to a central location for processing. There are three main types of data that we can collect and analyze, namely traffic data, which looks at the number of vehicles per hour and average speed per lane. The second type of data is air data. With this information, we can capture measurement of air quality over customized periods of time. And lastly, vehicle data, which allows us to see vehicle types, driver behavior, and speed. Let me share a success case with you. Currently, we have a project in Europe in which we're applying the analytics we mentioned today. At the entrance, we're applying license plate recognition for access control. Inside the parking lot, we have placed sensors to detect the number of empty slots. These sensors are also used to verify that cars are parked correctly and to detect smoke and fire. Also, license plate recognition has been applied to spots reserved for VIP and electric vehicles. These AI analytics run on an ASUS edge computer, which processes the inference and sends the metadata back to a central server for further analysis. In summary, these are the solutions that ASUS Iot currently offers to transform the transportation industry. First, license plate recognition for access control, occupancy to calculate the number of empty parking bays, applications for electric vehicles, smoke and fire detection, and traffic infraction detection. All of these solutions are paired with ASUS reliable hardware products, which have gone through the most stringent test to find the most efficient combination for each specific solution. These hardware and software bundles are created in partnerships with the ecosystem partners and officially certified by Powered by ASUS program. At ASUS, we are constantly looking for valuable partners to join forces with. We understand that the future of technology is open and collaborative, which is why we have created a Partners Alliance program in order to co-create solutions and go to market.
Thank you, Sylvia and ASUS team, for inviting me for this AI in Transportation webinar. My name is Siamek Nazari, and I'm the Global Sales Director for Transportation segments at Intel. And today I'd like to walk you through some of the changes and transformations that are happening in transportation by AI, right? By the implementation of AI that we see across the industry. So the coming 10 minutes, I will give you some examples and some use cases in which AI, but also how Intel and Intel software is helping to enable all these solutions. Just to kick it off, right? AI is really changing the cities and transportation environment. A lot of these implementations will, in some way or form, interconnect with each other and change our lives. For example, in transportation, we can improve our lives by just saving 60 hours either in traffic or in other transportation modalities. That's about 3 days of our time that could be saved by just implementing smart, intelligent transportation networks and technologies. So let me give an example of what we mean with transportation, specifically non-automotive transportation, which is my focus area. So if you look at the sub-segments within transportation, we have identified 5 categories: ships and ports, airports, railways, fleet management, and road infrastructure. And below that, you'll see some of the use cases, common use cases in which AI is used a lot for these industries. For example, security and surveillance, which you'll see across multiple segments, but also worker safety and smart parking that could be used at airports, at shipping ports, but also in road infrastructure. They also have their own specific use cases when it comes to AI. For example, you have ship-to-shore container scanning, or traffic monitoring for road infrastructure. For airports, you'll see turnaround time measurement for planes. Then in railways, you'll see occupancy detection for a cabin. And then for fleet management, for example, you could have anti-theft cameras or driver behavior monitoring cameras looking down at the vehicle. And the other piece is that a lot of these models used, AI models used for these categories and subsegments of transportation, they are actually quite common, right? So license plate recognition could be used for e-gates at a port, but also for smart parking. At the same time, you have object detection or object classification can be used in railways, but also in road infrastructure. Vehicle tracking, similar. So sometimes if you build a model, an AI model, you can reuse them in several subsegments within transportation, and that's making scaling possible. So, if you zoom in a little bit in railways, right, how is video analytics and AI changing that environment? There's many things you can do, but for example, you have cameras for object detection on the track, right? You want to make sure that at least you can see what kind of objects are on the track for the further distance in order to improve safety. But at the same time, you can also look at the passenger monitoring, right, or occupancy detection. Which cabin in a rail is actually full of people and crowded, and which one is more empty. That data can be shared with the users real time once you understand how you can collect that data, right? So think about occupancy detection in a cabin. In a way, similar to finding a parking space at a parking lot, right? Understanding if there is occupancy or not. And that use case is obviously a little bit different for railways than for parking, but the underlying thought is the same. We want to have real-time data about a certain occupancy level in a certain transportation modality. Another example that I can give is advanced fleet management, right? So as I discussed, right, heavy vehicles will be equipped more and more with aftermarket solutions, whether it's for the efficiency of the fleet or whether it's regulations, right? For example, in a public transportation bus, these could be regulations. So if you look at this across the board, right, you'll have lots of cameras or other sensors connected to this in-vehicle computer that needs to be able to process AI at the edge. So whether it's for predictive maintenance, idle monitoring, blind spot assistance for the driver, all of them will use some kind of a level of AI for the advanced fleet management solution. And one of them that we have actually helped to build on Intel's OpenVINO is driver behavior and driver management. I'll show you now how that looks like. So here you see an example of driver behavior. It's a reference implementation built by Intel to showcase what we could do with edge compute, industrial PCs, fanless PCs that go into vehicles as an aftermarket solution. And the example here is driver behavior to make sure that it assists the driver not to fall asleep, right? So when they start yawning, when they start closing their eyes or looking away, an alarm could be sent to them to make sure that they refocus on the road or at least take a coffee or tea break. Now, a lot of new vehicles, consumer vehicles will have this option already, but in commercial vehicles, a lot of times it might be lacking. That's why it's important to improve safety by using this AI solution for fleet management. Moving on road infrastructure, obviously we'll be talking about smart parking a lot, but it's the underlying and the bigger picture of how we can change the road infrastructure by using AI is first think about how do you consolidate workloads. So for example, if you have an intersection or if you have traffic signaling, you might see a lot of video systems and a lot of sensors with their own edge compute with their own gateways. You'll have multiple of them. Our idea here and our vision is that we can change this by consolidating the workloads. On top of that, have AI, low latency, in order to make sure that you can much better manage your assets within the AI workload, but also have much more options when it comes to upgrading your system. So for example, you can now have multiple cameras that are not per se super intelligent by themselves, but the edge compute that is next to it and is bringing all these sensors together enables the intelligence for them. So now you have a camera doing license plate recognition. The other one could send a signal to the traffic controller so that you could have first come, first serve kind of a traffic flow, right? So where you in the past had induction loops, you can now replace it by cameras and identify the vehicle, but also understand what type of traffic is crossing your streets. How many percent was truck, how many percent is bike, so that classification can also be done by edge AI implementation. Here is an example I wanted to show you that on the left side you'll see a collision detection, and on the right side you see an intersection monitoring system in which you can also not only count people at an intersection, but also be able to detect dangerous situations, right? You could see, hey, how many people are walking and how many dangerous situations exist in such a new intersection. So for example, you see here on the right side the alarm of pedestrians walking and cars still crossing the road, which could create a dangerous situation. So how do our partners scale AI at the edge, and how is Intel helping? So if you are not familiar with OpenVINO, please get yourself familiar because it's an amazing tool and it will make your life as a developer easy. Because once you have built a model on a supercomputer with GPUs and all kinds of other accelerators, and you use one of the well-known frameworks like TensorFlow or Caffe, you can now optimize that by using Intel OpenVINO. And that optimization means that you can now run your inference on a smaller form factor PC without a GPU, a lower power and high performance CPU from Intel. And you don't have to rewrite your software if you're scaling up in the CPU platform or scaling down. As long as it's running on Intel CPUs, OpenVINO makes sure that it will recognize what platform is running on and it will optimize accordingly. So this is one of the key elements in scaling AI with Intel platforms. So as you can see, OpenVINO is just one piece of the puzzle. When it comes to AI and IoT implementation, you can see that Intel has support for multiple layers and building blocks for developing intelligent systems in transportation and include AI on top of all of those. But it also comes to how do you integrate this with cloud systems like AWS and Azure? How do you connect this with Docker? How do you use platforms like GitHub to reach out to the developer community, etc., etc. So we have lots of support and building blocks for you and for partners to enable AI and scale AI as quickly as possible. So with that, thank you very much for inviting me for this webinar, ASUS team, and looking forward to collaborate on the future of transportation and the journey ahead.
Today, I would like to introduce a fundamental edge AI feature, automatic license plate recognition, also known as ALPR or ANPR. I will explain how ASUS uses this solution to contribute to smart transportation, and I hope that this will spark your business imagination. ALPR is a technology used in public surveillance to capture the images of vehicles and identify registered license plates. ALPR also offers real-time insights that leverage object detection and recognition technology to identify license plates and vehicles. According to data from Grandview Research, the global road safety market was valued at $2.88 billion in 2020, and it is expected to expand at a compound annual growth rate of 12.4% from 2021 to 2028. In this market, demand for automatic license plate recognition is second only to traffic light control, capturing the largest share in 2020 and contributing over 25% of the overall market revenue. It is also worth noting that the ALPR market has been segmented into stationary and portable systems. ASUS Edge AI can fulfill needs across both segments using mainstream camera vendors. ASUS provides a solution-oriented combination of essential hardware, AI algorithms, and business logic, which helps our customers accelerate their development and deployments. ALPR functions can also be adapted to many other scenarios, such as active surveillance, VIP car hospitality, managing an emergency vehicle entrance, etc. Unlike other AI solutions, the accuracy of ALPR needs to be as close to 100% as possible. That's because the results of license plate recognition are directly connected to the judgment of billing, gate control, electric vehicle charging services, and even the enforcement of technology laws. Many potential locations for ALPR are also unmanned. Once errors are introduced, operating costs can go up, and the user experience will be deeply affected. Here are some of the key features of ASUS ALPR solutions. The first one is wide-angle support. Wide-angle skew correction enables superior positioning flexibility for camera deployment. Angle-independent camera placement allows for the avoidance of foreground obstructions, such as an EV charging station cable. A single scan can detect and identify the registration plates of two parallel parked cars for additional efficiency. Secondly, support for various light conditions. This means that climate filtering and light correction enables recognition even in rainy, reflective, and blurry conditions. Works in diverse illumination conditions and mounting scenarios, from low-light parking areas and outdoor security gates to squad car dashboards. And thirdly, novelty license plate noise reduction. High-performance deep learning algorithms enable accurate framing of a license plate boundary, minimizing the risk of misidentifying custom plates. Fourthly, easy deployment and cost-effectiveness. Thanks to deep learning image processing technology, a 2-megapixel camera is sufficient for vehicle plate recognition. ASUS offers sample code and APIs to easily integrate webcams and IP cameras. In parking garage scenarios, Edge AI detection with 2 or 3 synced cameras is possible. And because a single scan from one camera can cover 2 nearby parking spaces, hardware costs can be minimized. Now, I would like to give you 2 real-world case scenarios where ASUS ALPR can help a customer build a smooth parking experience. With the popularization of electric vehicles, problems of insufficient charging equipment and improper parking space occupancy have emerged. ASUS ALPR offers several solutions to overcome these issues. For example, one can install a parking spot ground lock controlled by membership access or charge users an occupancy fee based on parking time. This all requires accurate license plate recognition along with edge-based peripheral control capability. Also, billing for on-street parking is a time-consuming task. The ASUS ALPR Dev Kit assists in delivering a highly automated system. The main challenge in this field is that the lighting conditions around the front and rear of a vehicle are highly variable. Additionally, there can be an unexpected duration of parking occupation that affects the parking space turnover rate. ASUS ALPR can provide both accurate license plate recognition and parking space occupation status. Plus, a vast amount of useful information leveraging key object detection can be reported to the backend effectively. So that is the overview of ASUS license plate recognition technology. If you have any questions at this time, please send us a message. You can also scan the QR code on the screen and leave your information for more details. Thank you. We will now start our Q&A session. We have received many questions, but as we have limited time, I will only select a few. So the first question says, recently many AI algorithms have been directly embedded in IP cameras. As a key player of IoT edge computers, how does ASUS see this trend? This is a very interesting question. At ASUS, we are already thinking of building the algorithms into partner cameras in the future. However, we think that edge computer still has strength in many fields. For example, one edge computer can support the recognition of multiple IP cameras, which can cut the cost. Secondly, the inference results can be directly controlled through GPIO, USB, or wireless interface. And lastly, compared to SoC on IP cameras, on edge computers, the algorithm can be greatly optimized and easily extended. Okay, the second question is, does ASUS Iot offer software trials? Yes, so we offer an ALPR trial version running on Tinker HR, which is our board-level device, and it's optimized with NVIDIA Jetson Nano. You can Google ASUS Iot ALPR to visit our official website and provide your information on our inquiring form. And the third question is, I'm interested in the Partners Alliance program. Can you explain in more detail? So the goal of the Partners Alliance program is to recruit different kinds of partners in the ecosystem. We welcome machine builders, AI software vendors, or big data analysis software providers. And with these partners, we integrate our products from hardware software bundles or integrated software suites. We also need distributors and resellers, and of course, system integrators who are key to the deployment and scaling stage. The idea is to build an ecosystem and co-create solutions that are easy to deploy, plug and play even. How does this translate into specific actions? We go to meetings together, we create POCs, we assess and deploy projects together. In terms of marketing actions, we often participate at events together, create joint marketing campaigns, social media content, and co-create sales material. This concludes our online event today. To get in touch with us, you can scan the QR code on the screen to get more details. Thank you and see you next time.